Hello everyone, this is Dhanjit and you are watching me on my YouTube channel Reaction Concept. So students, we have already discussed and we have discussed some basics about how rate of a reaction depends upon concentration of the reactant. Okay, so we have discussed some concept in the last class, and in this video we'll discuss about some numerical based on those concepts. Okay, so the structure of the numericals based on two types of concept will be there. Numericals would be of two types. In the first one, you will be given the rate of the reaction and reaction of both will be given. Okay, what data you will be given? You will be given the reaction and the rate law for the reaction. Okay, then you are asked to some dependence, concentration dependence based on that data. And the second one type, reaction would be given to you, but the rate law would not be given, and you are supposed to find out the rate law. In spite of rate law, there will be some data in the question. Suppose unit of rate constant, okay, some concentration versus rate and mechanism of a reaction. This kind of data might be given to you. Okay, half-life period, you might not familiar with the term half-life period. We'll discuss on later on. Okay, this kind of data would be given to you. Okay, so numericals would be of two types. One is in the numerical, the rate and the reaction and the rate law might be given to you, and the second one, the reaction is given to you but the rate law would not be given to you. In spite of that rate law, some data would be given to you, and these data are like unit of K, unit of rate constant, concentration versus rate, mechanism of the reaction, half-life period. This kind of data might be given to you. Okay, and you have to find out what is the rate law. So let us discuss some problems from the type 1 format.
So here is the first problem you are discussing. In the question, a reaction is given, okay, where twice of A, thrice of B and 4 of C react with each other and give you twice of D. All are in gaseous state. Both product and reactant are in gaseous state. It is also mentioned that the volume of the reaction chamber, it is V equal to 3 liter. Okay, and in the question, the rate law of this reaction it is given. It is given as K into A to the power half, B to the power 0 and C to the power 2. And at 2 instead, at initial condition at a time t, their concentration or number of moles of the reactant are given at initial condition and at a condition where t equal to t second. You consider it is as a t equal to t second. If it is said that if the rate of the reaction at this condition, at this state, at initial state, it is R1, and at an instant, at any instant, it is R2, what will be the ratio R1 by R2 by R1? Okay, we have to find out the ratio of the two rate at different conditions. Okay, so from the given data of the molecules of the reaction, we can find out the concentration of the reactant at a instant t. So you see here 20 moles of A is there at initial condition. At a instant t equal to t second, 15 molecules of A is there. Okay, that is 5 moles of A is reacted here. Since 5 molecules of reacted, A is reacted, since from the stoichiometry we can say 2 moles of A can react with 4 molecules of C. So, since 5 molecules of A is reacted, therefore 5 molecules of A will give you 4 by 2 into 5 molecule of C. That is 10 molecule of moles of or molecules of C is reacted. Since 10 molecule of C is reacted, remaining will be 40 moles. And you see the number of moles of product would be also 5, because 2 moles of A will give you 2 moles of D. Since 5 moles of A is reacted, and it will give you 5 moles of D. So concentration of A here would be 5 by 3 liter, and concentration of C would be 40 by 3, and concentration of D would be 5 by 3. Since all are in gaseous state, for gaseous state concentration of gas, it is given by number of moles divided by volume. Okay, so let us write the expression for R1. It would be, let us first write the R2. What would be the expression for R2? It would be the K into A to the power half into C to the power 2. So K into the concentration of A would be 15 by 3 and 40 by 3 whole square, whereas R1 would be K into 20 by 3 to the power half and 50 by 3 to the power half square. Okay. So R2 divided by R1 would be K1 15 by 3 half 40 by 3 square divided by K into 20 by 3 half 50 by 3 square. If we simplify this, then this 3 will be cut out and R2 divided by R1 would be remain as 50 by 20 root over and 40 by 50 whole square. It would be 3 by 4 and 16 divided by 25. So this is the ratio of R2 and R1. Okay, so this is how you have to solve the questions if rate law of the reaction is given and some data based on the reaction is given to you. So here is a question. In the question here also the reaction is given and rate law is also given, and a data based on the concentration of the reactant and product is also given. Okay, it is said that when the concentration of A it is 0.08 and concentration of B it is 0, the rate of the reaction is 10 to the power minus 2. Okay, this data it is given, that is initially it is T equal to 0 because the concentration of B it is here, it is 0. Okay, no product is forming, so it should be the initial concentration. It is asked that when the concentration of B it is 0.08, what will be the rate of the reaction? Okay, so let us consider the reaction first. So in this reaction it is given that at initially the concentration of air it is 0.08 and it is 0. At the initial stage it is like this. When it is said that when the concentration of B it is 0, what will be the rate? In the question it is asked so. Okay, so what will be the amount of A when the concentration of B it is 0.08? You see 2 mole of B it is produced from 1 mole of A. So 0.08 mole of B would be produced from 1 by half into 0.08 of A. So it would be 0.04. So to produce this amount of B, there should be the number of air reacted, it should be 0.04. Okay. So amount of A at time T where 0.08 of B is there, it would be 0.04. Okay. We just got this value by subtracting from the initial concentration. So it is the concentration of A and it is the concentration of B at T equal to T second. So we can write here for the above condition, these are the two conditions, condition 1 and condition 2. For the condition 1, we can write rate of the reaction, rate 1, it would be the K into A to the power square, that is K into 0.08 whole square, where rate 2 at condition 2 it should be K into A square, that is 0.04 whole square. Now you divide rate 2 divided by rate 1. So rate 2 would be 0.04 whole square, K into 0.08. So K cancel out. You will have 16 divided by 64, 10 to the power minus 4, 10 to the power minus 4. So 1 by 4 would be there. Okay. Again, you know that the rate of the reaction at initial concentration, that is R1, it is given that 10 to the power minus 2. So R2 would be, rate 2 would be 0.25, 1 by 4 it is 0.25 into 10 to the power minus 2 mole liter inverse 1 second inverse 1. So this is the rate of the reaction where concentration of the product, that is B, it is 0.08 mole per liter. Here is another type of question. In the question, reaction is given to you and concentration versus rate data is given. Okay, you are given a concentration versus rate data is given. Okay, But in the question, the rate law is not given to you, and it is asked to find the rate law of the reaction and overall order of the reaction. Okay, this can be find out when we find the rate law. And it is asked to find out also the rate constant and the rate of formation of PQ, that is product, when concentration of P is 0.06 and Q it is 0.03 mole per liter. Okay, so let us consider the rate law of the reaction. It is rate law, it is K into P to the power alpha and Q to the power beta, where alpha and beta are the order with respect to P2 and Q. Okay. So from the above data, if we consider the first data, what will be the rate? Rate it is 0.03 K into 0.01 to the power alpha and 0.0 to the power beta. Number it as one equation. When you put the second data, this second data where concentration of P it is 0.02 and Q it is also 0.02, and it is said that the rate of the reaction would be 2.4 into 10 to the power minus 3. So our rate would be 2 into 2.10 to the power minus 3, 2.4 into 10 to the power minus 3, K into 0.02 to the power alpha 0 into to the power beta. Number it as equation number 2. Whereas in the third case, the rate it is 4.8 into 10 to the power minus 3 and concentration of P it is 0.01, where it is 2 it is 0.04 to the power beta. Number it as 3. So these are the three equation. Okay, so you see in this equation the concentration, the alpha and beta value is unknown for each reaction. Okay, so to find out the alpha and beta, we will divide the equation. Suppose we will divide 2 by 1 or 3 by 1. We will divide in such a way that one form, that is beta, should be cut out. You see, if you divide 1 divided by 2, then this term, that is 0.02 and 0.02 to the power beta, from both the equation will be cut out. We will left out with only alpha value. Okay, K and K also be cut out. So from that way we can find out the alpha value. So let us see how we will calculate the alpha value. First we will divide equation 2 divided by equation 1. Okay, so rate of the equation 2 is 2.4 into 10 to the power minus 3, where it is 1, it is 1.2 into 10 to the power minus 3. K into concentration of P it is 0.02 to the power alpha and 0.02 to the power beta. For 1 it is K 0.01 to the power alpha and 0.02 to the power beta. Okay, we divide equation 2 by equation 1. So in this case you see K will cancel out, this term and this term also cancel out. Here 10 to the power minus 3 also cancel out. So we left out with, here it is will be 2 times, 2 into it is also 2 times. Okay, 2 to the power alpha. This means alpha is equal to 1. Similarly, we will divide equation 3 divided by equation 1. So 3 we have get 4.2 into 10 to the power minus 3, it is the rate. So this will cancel out. Okay, these terms will cancel out. So you will have only 4. This will goes for 4 times, and you will have this will 2 times. Okay, so 2 to the power beta. So beta would be 2. Okay, so alpha, the value of alpha, it is 1, and beta would be 2. So rate of the rate law of the reaction K into P to the power alpha and Q to the power beta. So it would be K into P to the power 1 and Q to the power 2. So order of the reaction would be 1 plus 2, it is 3. It is a third order reaction. Okay. So we have find out the rate law and overall order of the reaction. So we have to find out the rate constant. So to find out the rate constant, we'll just put the value of concentration. We'll just consider one value of concentration and the rate, and we'll put on the rate law. Then rate constant will be find out. And this 2 and 3 is up to you. You comment on the comment section below whether you can do it or not. If you have any problem, you can ask me on the comment section below. And this is it for the today's class, student. We'll see in the next class. Thank you.